So we started with the question, what are the CO2 levels and the CO levels emitted from a car's exhaust? The car that we will be using is a 2006 model Toyota Prius. The project is mounted in the trunk of the Prius, with the sensors mounted on the bumper in front of the exhaust. The two sensors we will be using are an MQ-7 CO sensor and the Telare 6004 CO2 sensor. Here we have our circuit in the actual trunk Tupperware container with the fritzing version of the circuit in the upper right and the MQ-7 sensor diagram in the bottom right. Now, the epitome of a sensor is normally 3 leads, power, ground, and the output. But for the MQ-7, it requires another power lead in order to power the heating coil, because it requires a relatively warm operating temperature of somewhere around 40 degrees C in order for it to actually take data accurately. Our circuit consists of the Arduino power board, the breadboard, which is connected to an SD card shield, as well as our sensors. Now, the MQ-7 also required a load resistor, which we are using a 10 kilo ohm load resistor for data taking. We had run several tests beforehand using 9-volt batteries and determined the average lifespan of a new 9-volt Energizer battery to be approximately 74 minutes worth of data taking. Now, we were going through 9-volt batteries pretty fast, so we decided to build the Carduino, as Dr. Matt refers to it, shown here. The Carduino allows us to plug straight into the cigarette lighter of the Prius and then power the Arduino directly from that 12-volt power source. Here we have a short clip of our LEDs being powered. The Arduino and SD card shield both have LEDs on, indicating that they have sufficient power. And the CO2 detector has a blinking LED, showing that it is functioning. The CO detector does not have an LED indicator, however it does warm up over time. Here we have our simple Arduino code, which reads the data from the CO and CO2 sensors plugged into the 2 analog ports of the Arduino. The code then writes to the SD card, which we can then read into MATLAB for plotting. To convert from the Arduino readout analog to parts per million for the CO2, we could use the datasheet, which we took the voltage from the analog pin multiplied by the 5-volt supply, then divided by the 1024 bits of the Arduino. Then we multiplied that by the operating voltage and the maximum parts per million of 2,000 parts per million divided by the 4 volts to convert from voltages to parts per million CO2. The MQ-7 datasheet did not clearly display which voltages corresponded to which parts per million of carbon monoxide. So we did some experimentation, and the original Arduino code presented does not have that experimentation in there, but we determined that a multiplication of what we have present in the code by 800 gives us true parts per millions of CO. Each of the sensors takes about 3 minutes to warm up and start taking data in a real manner. We've noticed, however, that the CO2 sensor, since it only reads from 10 parts per million to 2,000 parts per million, is actually saturated when you accelerate, even at low velocities at high gradients. So going from 0 to 25 uphill will completely saturate it up to 2,000 parts per million. However, if you were going, say, 45 on like more flat terrain, you could see it hovering around maybe 1,500 parts per million for CO2. However, we also noticed that the CO sensor did not oversaturate itself during the runs. So because of this, we have some real values from the CO sensor, and we can see that accelerating up to freeway speeds, it will produce over 1,600 parts per million of carbon monoxide, which for humans, inhalation of that level of several minutes would be lethal. So a third plot here has an interesting spot starting at around 1,100 seconds. Now, this corresponded to an RV having burned out on the side of 101, and thus making 101 a parking lot. Now, I started at the top of the hill and was able to just simply coast down the entire way. Since this is a hybrid car, the gas part of the engine can shut off automatically. So as you see, while I'm just coasting, I'm not accelerating at all, you see the CO and CO2 levels just drop off and taper down until it finally opened back up and we were able to get back up to freeway speed. Now, from this data, we can see that it takes the CO2 sensor about 5 minutes or so to go from saturated 2,000 parts per million back down to normal levels. And the reason why it takes long is because we have those yellow hoses. In order to protect the CO2 sensor, we had to wrap it in bubble wrap, and that made it so that we couldn't have it directly in front of the exhaust. So through this project, we learned how to solder different materials. We learned how to splice two leads together in order to make the Arduino. We did some soldering for the MQ-7. With the help of Jim, we were able to solder the CO2 sensor, the Teleray 6004 as well. And we determined the calibration of the CO sensor, and also that, hey, your car will output well over 2,000 parts per million.